Hi, hello. Today we shall take average and instantaneous rate of reaction. In the previous video, what we have done was we have started chemical kinetics, and some general discussion was there related to chemical kinetics. We have discussed rate of reaction and how much rate of reaction is determined. That is what we have discussed. So today we will take average and instantaneous rate of a reaction. Welcome to chemistry here once again. So average and instantaneous rate of a reaction means if we are talking about average rate of reaction, then what we say is change in concentration with time is called the average rate of a reaction. The change in concentration may be for a reactant as well as for a product. So that is what average rate of a reaction, and it can be calculated like R average is equal to change in concentration in a given time and that time taken. Okay. Suppose in 10 minutes time the change in concentration is like 2 mole or 3 mole, then what will be the average rate of reaction will be 2 upon 10, okay, 2 upon 10. So that will be 0.2 mole minute inverse, because we have taken 10 minutes. If we will take the time in seconds, then that will be equal to this much mole second inverse. Okay. So that is what is average rate of reaction. For instantaneous rate of reaction means what? The change in concentration of one of the reactant at a particular moment of time, or what we can say, the decrease in concentration of one of the reactant at a particular instant of time, and or what we can say, the increase in concentration of product at a particular instant of time is called instantaneous rate of that reaction. Suppose we have to calculate rate of reaction at 10th minute or 600th of a second. So that particular moment, what is the rate of reaction? That is what is called a instantaneous rate of a reaction. How to calculate instantaneous rate of a reaction for a general reaction like this, N1A plus N2B, where N1 and N2 are number of moles of A and B, are converting into N3C plus N4D, where again N3 and N4 are number of moles of C and D. Means these are the stoichiometric value of reactant and product. So how to calculate R instantaneous? That will be equal to minus 1 by N1 dA upon dt, where dA is equal to what? The small change in the concentration of E, and dt is the small change in time. Okay. Delta means a bigger change, that is delta. Okay. But if you are writing d or dA upon dt means there is small change in concentration and small change in time. Okay. Likewise is equal to minus 1 by N2 dB upon dt will be equal to 1 by N3 dC upon dt, and will be equal to 1 by N4 dC upon dt. If we want to calculate the instantaneous rate of disappearance of A, that will be equal to minus dA upon dt is equal to N1 R, where N1 is what? Number of moles of reactant A. It means the disappearance of A will be equal to nth time of the average rate of reaction. Am I right? So likewise minus dB upon dt will be equal to N2 R instantaneous, or plus dC upon dt is equal to N3 R. Means if the rate of reaction or instantaneous rate of reaction is R, then it will be equal to and 3 times of that rate, whether it is instantaneous rate or whether it is average rate. Okay. Likewise, for appearance of product D will be equal to d upon dt and is equal to n for r. So from this equation we can calculate separately the disappearance rate and as well as appearance rate of a product. Graphically we can also calculate the average rate and instantaneous rate of a reaction. How to calculate then? We can calculate with reference to reactant as well as with respect to product. If we are calculating with respect to reactant, then we know that we are taking the reactant A. Okay. Then what will happen? The concentration of A will decrease with time and we will get the graph like this, a parabola. Okay. This graph is showing that concentration of A is decreasing with time. Suppose the concentration of A is A1 at this instant of time. At time t1 the concentration, if it is A1, then at time t2 it will decrease to A2. Okay. And how we can calculate then average rate of reaction? The final concentration minus initial concentration minus final concentration upon the final time upon initial time. Am I right? So that will be equal to what? Minus dA upon dt, minus dA upon dt, because this is a bigger instant of time we are taking. So what we can say, like this is average rate of a reaction. Okay. Now suppose we have to calculate rate of reaction at point t, at time t, at moment t, then that will be the instantaneous rate of a reaction. And how to calculate the instantaneous rate of reaction? Let us draw a straight line over this time axis, and that is cutting this graph at point say O. Okay. Suppose at this point we have to calculate the instantaneous rate of reaction. Then what we should do? We have drawn this straight line at this time axis. Okay, that will cutting at time t and at point O over this graph. Then what we have to do? Let us plot a tangent over this point, tangent like this. Okay, and that tangent will touch this graph at this point of time. Now by calculating, by extrapolating this rectangular triangle, how can we calculate the instantaneous rate of reaction? Now is this is a small change in concentration, this will be equal to small change in concentration of A, and this will be equal to a small change in time. So the R instantaneous will be equal to minus dA upon dt. Okay. So like that we can calculate the instantaneous rate of a reaction. Am I right? If we want to calculate the average rate and instantaneous rate of reaction with reference to product, then of course we will get a graph like this. If we are taking here C, product C as our reference, then the concentration of C will increase with the time, because the concentration of product increases with the time. Am I right? So suppose at time t1 the concentration is C1 and at time t2 it increases up to C2. Then the average rate will be equal to C2 minus C1 upon T2 minus T1, and that will be equal to delta C upon delta T. That is how we can calculate the average rate of a reaction. If we want to calculate the instantaneous rate, then likewise we will draw a straight line over this time axis. Okay. So at this point of time, means at t time, how to calculate the instantaneous rate? Again we will extraplot a tangent over this point, okay, and we will make a rectangular triangle, and by using this difference, that is small change in concentration of C dc, and upon time interval, that will be equal to tangent. Am I right? So it means what? The instantaneous rate of reaction will be equal to slope of this tangent. Slope of this tangent. Am I right? Likewise here, the instantaneous rate will be equal to slope of this tangent. So this is how we can calculate by extraplotting the graph with reference to reactant as well as with respect to product, and extraplotting a tangent, and then can be calculated R instantaneous. Okay. For instantaneous rate at time t, a straight line is drawn to cut the curve at a point corresponding to the time t. Then a tangent is drawn to curve at that point, that particular point, and that is what we have done. Okay, this is what is written here, and that is what we have discussed as well. Now let us take an example how to write the instantaneous rate of reaction for a particular reaction. Let us see how to write it. That is 5 Br negative, 5 Br negative aqueous plus BrO3 negative, okay, and that is also aqueous, means the reaction is taking place in aqueous medium, plus H plus, means the reaction is happening in acidic medium, that is 6H plus, will be equal to what? Br2 plus 3H2, 3Br2 plus 3H2. Now how to write the instantaneous rate of reaction for this reaction? So how can we write? The R instantaneous will be equal to minus 1 by 5 d Br minus upon dt is equal to minus d BrO3 minus upon dt. Okay, this is just to show the medium, so need not to take it. Okay, will be equal to 1 by 3 d Br2 upon dt will be equal. This is again like H2O, so we need not to even calculate this, and even if we want to calculate, we can do that. Will be equal to 1 by 3 d H2O upon dt. So this is how we can write the instantaneous rate of for this reaction. Now if we want to calculate for particular bromide ion the instantaneous rate for disappearance of bromide ion, then what will be the rate of disappearance of bromide ion? That will be equal to minus d Br minus upon dt will be equal to 5 into R instantaneous. So it will be 5 times to the rate of a reaction, 5 times from rate of a reaction. Likewise, this will be equal to instantaneous rate, and this will be equal to 3 times, okay, means appearance of bromine, that is d Br2 upon dt is equal to 3 into R instantaneous. Okay, so this is how we can calculate the instantaneous rate of disappearance of bromide ion and appearance of a bromine, okay, from the stoichiometry of that reaction. If we are given these values, okay, given these values, we can easily calculate either R average or R instantaneous, okay. So this is what the average and instantaneous rate of a reaction. So that's all for now. Later on we will take the factors affecting rate of reactions, and then we will take rate law and rate constant in the next video. Till then, take care. Happy chemistry.